Hello, ladies and gentlemen. Today we're going to be talking about how to solve radical equations. So we'll now apply our knowledge of roots and exponents in equations and not just expressions and operating and simplifying and all that fun stuff. We'll actually get to equal signs with radicals, okay? So what you're going to need are your notes, a pen or pencil, and probably a calculator. So some things that we have to know when we're solving equations, we have to remember to get that variable, or in our examples today, the x alone, and remember our inverse operations, like what undoes something when we're solving, adding and subtracting undo each other, multiplying and dividing undo each other, square rooting and squaring undo each other, cubing and cubed rooting undo each other. And actually, in the next video, we'll talk about reciprocal fractions. And of course, when we're solving in Algebra 2, we always check our solutions so that we don't get extraneous solutions. So our last step is always going to be checking our solution to make sure it's not extraneous. Okay, so for our first example, we have 2 times the cubed root of x minus 3 plus 7 all equal to 11. So when we solve these guys, in order to get the x alone, we have to isolate this cubed root of x minus 3. So treat that whole thing like as a variable that we're trying to get alone. So we want to subtract the 7 first. So we get 2 times the cubed root of x minus 3 is equal to 11 minus 7 is 4. Then we're going to divide, because this is being multiplied, by 2. So then this will cancel the 1. So we just have on the left-hand side the cubed root of x minus 3 equal to 4 divided by 2 is 2. So now is where we have to get rid of this cubed root. And we just talked on the last slide that the opposite of rooting something is raising it to that power. So whatever we do to one side of the equation, we have to do to the other side. So in order to cancel this cubed root, we're going to cube both sides. So that means that my left-hand side becomes x minus 3, and 2 cubed is the same thing as 2 times 2 times 2, which would be 8. Then we're going to add 3 to both sides, and we get x is equal to 11. But before we get super excited if our answer is final, we better check way back up in here and plug in the solution that we got for x to make sure it's not extraneous. So I'm going to do that in blue pen. So we have 2 times the cubed root of 11 minus 3, all plus 7 is equal to 11. So now that we're simplifying or trying to get one value equal to another, let's start from the inside. So 11 minus 3 is 8. So we have the cube, 2 times the cubed root of 8 plus 7 equal to 11. And the cubed root of 8, if you use that perfect table of our squareds, cubes, fourths, fifths, we know that the cubed root of 8 is 2. So that outside 2 is getting multiplied by 2 plus 7 equal to 11. Well, 2 times 2 is 4. And the question is 4 plus 7 equal to 11? And the answer is yes. So yes, x is equal to 11 on my number 1. Okay, here's another example. Now we have a little bit different of a situation. We have a cubed root on the left side and the right-hand side of our equation. So in order to get the x's alone, we actually have to get rid of that root or that radical first. So what undoes a cubed root is a cubed power or a third power. So if we take both sides to the third, that'll actually cancel it out for us to just leave us to the equation 2x plus 3 is equal to x minus 1. And now we just solve like normal. So get the x's on one side. I'm going to subtract x. We have x plus 3 is equal to negative 1. Subtract 3 to get x alone. And we get x is equal to negative 4. But before we say that that is our solution, let's plug negative 4 into the original equation. So we have 2 times a negative 4 plus 3, and that's all underneath a third root, is equal to the third root of negative 4 minus 1. So I'm working from left to right now. 2 times a negative 4 is negative 8 plus 3, and that's still underneath our cubed root. We know that negative 4 minus 1 is a negative 5. Okay, now we have negative 8 plus 3 is negative 5. So the question is the cubed root of negative 5 the same thing as the cubed root of negative 5? Sure it is. And we can't even simplify it anymore, but we don't need to because we know we got the same thing on both sides, which means that x minus 4 is my solution for number 2. Okay, number 3, it's a little different. So we have x plus 1 on the left-hand side, and we have the square root of 7x plus 15. Well, I could subtract 1 from both sides, but that would give me x is equal to the square root of 7x plus 15, all minus 1 on the outside. But that doesn't help me get x alone. So what I'm going to have to do is actually square to get rid of that radical first. So in order to get rid of this square root, I have to square both sides. So that's going to cancel this guy, but when we have x plus 1 squared, remember that's the same thing as saying x plus 1 times x plus 1. So we actually have to factor that. So that's going to be x times x, which is x squared. Then we have x times 1, which is plus 1x. Then we have 1 times x, which is plus another 1x. Then we have 1 times 1, which is plus 1. And that's all equal to 7x plus 15. And we can combine like terms, so we get x squared plus 2x plus 1 is equal to 7x plus 15. Now I have an x squared and an x involved, so you got it, ladies and gentlemen. We are going to have to factor this baby or get one side equal to 0. So I'm going to subtract the 7x and the 15 from both sides. So x squared, we have 2 minus 7 is a negative 5x. 1 minus 15 is a minus 14. So now we have to use our trinomial patterns to figure out how to factor x squared minus 5x minus 14. So x goes in front. Now we need to figure out two numbers that multiply to 14 and add to a negative 5. Well, that's going to be 7 and 2, and in order for the 5 to stay negative, I'm going to have a negative 7 and a positive 2. So if I set both of those factors equal to 0, I get x is equal to 7 and x is equal to negative 2. But before we get too excited, we got to check our solutions to make sure we don't have any extraneous answers. So I'm going to try number 7 first. So I have 7 plus 1 is equal to the square root of 7 times 7 plus 15. So 7 plus 1 is 8. 7 times 7 is 49 plus 15. 49 plus 15 is 64. So we have the square root of 64. So is 8 the same thing as the square root of 64? You bet it is. So we know 7 is a solution. I'm going to try negative 2 in a different color. So let's try it in green. So if we have negative 2 plus 1 is equal to the square root of 7 times the negative 2 plus 15. Sorry, I'm running out of room. Negative 2 plus 1 is a negative 1. 7 times negative 2 is negative 14 plus 15. So now we have a negative 1 is equal to the square root of a positive 1. But a square root of a positive 1 is 1. So the question is negative 1 the same thing as 1? And so they're not equal, which means that x minus 2 doesn't work or is an extraneous extra solution. So if you just want to circle the one that works and then cross off the one that's extraneous, I'm perfectly fine with that. So those are the only 3 examples we're going to cover in today's video, and we'll tackle more problems in the next video on rational equations. So I want to thank you all for taking good notes, and I'll see you soon.